Long before Newton's head got hit by a falling apple, there is no doubt that his grandfather had been hit by something. So do other people in this world, either by a coconut, soccer ball, or swinging saloon door. All of it has one thing in common. They exert forces on you. Forces change the state of the object through the act of pulling, pushing, hitting, etc. They can be in the same direction or opposite direction, like parallel forces. When the parallel forces have the same direction, we call them like parallel forces. Let's observe the apple that fell on Sir Newton's head. Instead of one apple, consider a basket full of apples falling from the tree, whose basket mass is neglected. The weight of the system is only due to the weight of all the apples in it, which equal to the force of gravity. This also means the weight of every apple is equal to the force of gravity that acts individually on each of it. As the gravity pulls downward to the center of the earth, the weights of apples also act vertically downward in a uniform direction. In other words, the weights of apples are the parallel forces of each other. Another example is when people push an apple cart together. They exert forces in the same direction, and therefore, those forces are parallel forces, unlike parallel forces. So now we can define unlike parallel forces as parallel forces that have opposite directions from each other. Consider an apple suspended by a string. The forces acting on it are weight of the apple acting vertically downwards and tension in the string pulling it vertically upwards. The two forces are parallel, but opposite to each other. Thus, they are called unlike parallel forces. So what matters here is the direction, but knowing the force magnitude and the net forces are equally important, however. We can find the net forces for parallel forces or non-parallel forces by calculating resultant force. A resultant force is a single force that has the same effect as the combined effect of all forces to be added. One of the methods for the addition of forces is a graphical method. This method adds the vector of forces by using the head-to-tail rule. Suppose we have two vectors, A and B. To add them, we take vector A and then draw vector B, such that its tail coincides with the head of the first vector A. Similarly, draw the next vector for the third force, if any, with its tail coinciding with the head of the previous vector, and so on. The resultant vector force, vector R, is drawn such that its tail is at the tail of vector A. The first vector, while its head is at the head of vector B. The last vector, vector R, represents magnitude and direction of the resultant force. Another method to calculate resultant force is by splitting forces into their components in the coordinate system, x component and y component, and calculate the sum of each component. Splitting up a force into these two components is called the resolution of force. Consider force F making angle theta with x-axis. We start by projecting force F into its x and y component as two perpendicular lines. The horizontal line is the x component of the force, while the vertical line is the y component of the force. The component of the force can be found by trigonometric ratios. Comparison of horizontal line to hypotenuse, or cosine theta, is equal to x components towards the force, which resulting in Fx equals F cosine theta. The comparison of vertical line to hypotenuse, or sine theta, is equal to the y component towards force. This can be rearranged as Fy equals F sine theta. Now, if you have F2, you can do the similar way as F1. Have the sum of each component and calculate the resultant of force by using this formula. Resolution of force can be used reversely to determine the value of force, and the most important thing is they can be used for almost all force-related problems. Now go and make a good use of this theory for the advancement of mankind.